So, how not to use Docker? From where did we get this idea, you know? Well, when you are dealing with a new toy, with a new tool, with a new framework, it is equally important, if not more important, to know how not to use it, rather than the intros on how to set it up, how to run it, and so on. Take it, for instance, Stack Overflow. You can see it as a large collection on how not to use stuff. Usually a question starts with, hey, I tried this and this, and the answer starts with, why would you do that? You know? And then keeps iterating on how you should properly use it. Right, so we mentioned here about microservices, and together with my team, we were in a product which deals with a tech stack like the one here. So we were having a simple dashboard UI to present to the users, written in React. Dashboard UI was relying on a dashboard API, a middleware proxy built up with Node. Was using some cache in Redis, persisted some users and preferences in MySQL. And that proxy would query out a data warehouse service, an endpoint which was built in Golang, relying on a data warehouse implemented in Redshift with some data pre-aggregated in Postgres. Simple, right? Obvious to anyone. Our first challenge when we entered into this setup was how we will see all these pieces working together, how we will debug all these pieces working together. And our first setup was based on Vagrant, good old Vagrant. Worked till we had only 2 servers, but when we had started to scale at 4 and 5 servers, that kept failing and failing. So we were thinking about Docker, right? And during my talk today, I will cover up 2 use cases. One use case would be, how would you populate a Docker container with a database with some presetted data? But let's not take the easy one. Let's say about a couple of millions of records to pre-populate in a presetted database. Sorry. And the second use case would be, how would you ensure that all these things come up together live and work properly together? All right, about databases. The generic recipe for Docker databases is depicted on the slide, but in short, it's something like start the container, install the database, and then search if the mounted volume has the right data in it. If it doesn't have the right data in it, launch the initialize scripts, right? And all you'll do would be to hook up those initialize scripts and start to do stuff there so that you have your database. All good and nice. We went to the production server. We made a dump of 60 million records, I think. We made some large text files with them and put them there. Well, 10 million records. What would happen? What do you think it happens when you start that process, when you start the Docker? Well, it's not, there's no brainer. I mean, it took like 10 minutes in average for the Docker container to initialize till we had the Docker running and we could start to do some real work there. This is because the inserts come one of the other. You could perhaps pack them in rows of 10,000 at a time, but still, it is not quite there. So we thought about it, and we tried to deviate from the nominal use case, and we proposed some alternate to that. So our initial thought was how we could move this whole initialization from the container startup to the image build. Because image build for us could take forever, or not necessarily forever. It wouldn't tax us during our use. And because of that, the modified flow would be like install the database software, then start creating the database itself. After we created the database, we would pack the whole thing together. We will compress it and leave it there. And then when the Docker container would boot up, it will search for the database folders that wouldn't be there. And instead of launching the initialize scripts, it will launch a script which will unpack the content that we just packed. Sorry. Okay. That was the use case that we applied, and we managed to go down from 10 minutes, roughly 10 minutes, to the normal use case of a couple of seconds, 15 to 20 seconds. Still, and most of that was only to unpack the compressed database folders. Still, we ended up in another problem in this dependency tree that I have drawn up here. You would need that first the database are ready. Then you will need that the API service will be ready. Then finally, you will be able to launch the UI. And this sequence, you have to do it, or you have to orchestrate it somewhere in Docker Compose. And I don't know how long have you joined the bandwagon of Docker, but some of you must remember, wait for it, .sh. Now, this whole script relies on a single command, basically, which is netcat for some port. And what it's supposed to do is to cycle on that command until the port is available. And after the port is available, it will run your Docker run command for you. We tried. According to the manual, according to GitHub, it went OK the first time. But as soon as we have started to complicate our use case, it stopped working for us. So we couldn't debug it. We couldn't make it run for us. Now, fortunate for us, with the version, I think 1.13 or 1.12, I might be mistaken here, Docker has introduced the health check mechanism, right? So suddenly our use case was slightly tailored. Everything was based on two command blocks. One of the first command block, it will stay in the definition of the Docker container itself. And what it will do, it will allow you to run a set of commands that you certify that that container is healthy, it's available, it's ready. And then the second block would run in the Docker Compose context, and it will allow you to set dependencies between containers based on that health check condition. And suddenly, like this, perhaps it will work. Ah, okay. Suddenly, with this whole workflow could have been instrumented by us by using the health check mechanism from within the Docker system. So two things that we have tried with Docker, and it really didn't went so well for us, but we have learned from it. First was the database setup use case, where we had lots of records, and how we were able to trim the boot up sequence for Docker containers, that we materialize those records faster, and synchronizing between a set of Docker containers where we would first use wait for it.ssh, long time, doesn't work. And then switch to health check support, which Docker now really provides for us and works fine. What have we learned out of our experience from this engagement, from this project? Well, first and foremost, yes. If you need a database, for instance, you just started a project and you need a database. Spinning up a Docker container with MySQL or PostgreSQL is ridiculously fast. It is bloody fast. But as soon as you involved in that millions of records because you want to pre-populate that database for your use case, now it starts to get really slow. What is the takeout from this? Well, use database containers with smaller amounts of pre-populated data, or if you really need, like we did, a large data set, then you'll have to pre-pack it and then unpack it during Docker construction. This use case that I have presented before, it's not really easy to take upon. It's really rather complex setup. There are about three large sections that you have to manage in Bash in the Docker file. And at least on our project, we are not so good with Bash, to be honest. Yeah, I know. Hopefully it won't leave a mark on my yearly review. Wait for it.ssh. Doesn't really work, sorry. So till we had the health check in there, all we did was to debug this wait for it.ssh. And yeah, health check, it's really flexible and enables us to put things modular, to put them in perspective, to keep them modular.